Welcome to the workbench of Hobby Paranormal, where we examine paranormal technology and create new tools for future exploration of the paranormal. For most paranormal investigators, an EMF meter and ghost hunting go hand in hand. It is seen as the essential tool for detecting activity. But standard meters have a few major design flaws. In this video, I'm going to explain exactly why the meter in your kit might be letting you down. But don't worry, if we're going to use an EMF meter in our investigations, let's build one from the ground up that is specifically designed with ghost hunting in mind. Now, a quick disclaimer before we begin. This new design has been heavily bench tested and offers superior range and sensitivity, but it hasn't been field tested in an active investigation yet, so there are no supernatural guarantees. Also, for those following my E-Field Detector series, I'm still working on that series and will have new updates for you when they are available. Before EMF meters were ever used for ghost hunting, they were designed for something much more mundane: hunting down electrical pollution from AC power lines and household appliances. Because of this, standard commercial meters are specifically tuned to power main frequencies, which is 60 Hz here in the US. For our investigations, this is a horrible place to look for paranormal EMF, with all that unfiltered ambient electronic noise, which in my opinion is a major flaw using them. The power mains are not relevant to the investigations and only create problems for us. EMF meters measure the electromagnetic flux density in standard units called a milligauss, which is just a fancy way of saying how strong the magnetic field is and putting a number to it. Lab-grade instruments like the tri-field meter or even the consumer K2 are calibrated to show the electromagnetic field in milligauss units. Let's be honest here for a moment. Most paranormal investigators don't care about the number of milligauss on their meters. We're looking for a spike in the environmental energy. The lab-grade calibration isn't really utilized or needed for this purpose. For our meter, we are departing from the calibration of the meter and adding a variable resistor so we can dial up or down the sensitivity of the instrument given the energy in the area. This is something that you could not do with a calibrated meter. There are EMF meters on the market that are single axis, such as the K2. Meters that rely on a single axis magnetic pickup coil can only detect fields traveling in one specific direction. If a field hits the meter from a different angle or you tilt the device, it completely misses the readings. Our circuit will address this 3D orientation problem, similar to that of the tri-field, by utilizing a 3-axis or triaxial sensor array. This will capture the electromagnetic fields across all 3 dimensions simultaneously, so nothing gets missed. I will mention that I'm trying to add one more improvement to our ghost hunting EMF meter that handles a common problem seen when using standard EMF meters in the field. This is still to be determined, but if it's possible, I'll add this to the design as well. To keep this build DIY friendly, we'll stick to common through-hole components. These are easy to source online, easy to handle, and perfect for breadboarding. The heart of this entire design is a pair of classic LM324 quad op amps. In my opinion, it's not really the best choice these days for modern instrument designs, but they are dirt cheap, available absolutely everywhere, and come in breadboard-friendly dip packages, and they'll perform well enough for what we're doing. On the other hand, a professional version of this project would use modern op amps, designed with surface mount components, laid out on a multi-layer printed circuit board that allows for better signal routing, sensitivity, and range. And it will offer more features on a compact board, thus making the overall instrument smaller than the through-hole component version. Something of this nature would be a better product, but it would be difficult to assemble, and it wouldn't be a DIY project. I plan to complete part 2 of this series by next week, and we will start breadboarding the circuit. So if you're interested in this series or the paranormal in general, then please hit the like button and subscribe to the channel. It costs you nothing to subscribe. It's completely free. Also be sure to click on the notification bell and select all notifications, because you don't want to miss the next exciting episode of the DIY EMF meter. One final announcement I have is that I have a Patreon page so that you can support the work I do here on YouTube. A link is provided in the show notes below. And with that, this wraps up part 1. I'll see you in the next one. Thanks for watching.